We've all used Photomath before, right? You have, haven't you? But check this out. If I click this, I don't know if you can see this or not, but what the answer that it gives me, it says this. It says X and this weird symbol, right? And then it says, this means real numbers. What in the world does that mean? Well, it means that there's no X that exists in the real numbers. And a lot of us will just write that, circle the answer, boom, move to the next one. But that's not right. Today I'm going to show you why that's not right and why Photomath is actually wrong. All right, now to be fair to Photomath, if you scroll down a little bit, it does have the correct answer, but it's definitely not the first answer that's listed. And a lot of us, again, just write that first answer and we're done. So today I'm going to show you how to do this one. And what I didn't have on here before is this is probably in your completing the square unit. All right, so we have to solve this by completing the square. That's how we're going to do today. And the reason why it doesn't work, I'll show you at the end, is because there's imaginary numbers. All right, that definitely is not in the real numbers. It's imaginary. Let's show you how to do this, okay? First off, these all have threes, or they're all divisible by 3, I should say. So if I do that quick math, 3 divided by 3, of course, just leaves me with x squared for this one, 2x plus 2x. Plus 3 equals 0. Okay, now when you solve by completing the square, we need to move our constant term to the other side. So if I do that, I'm left with x squared plus 2x. I like to leave a little space right there and then move it over by subtracting 3, leave me with a negative 3. Now we solve by completing the square. If you forgot how to do that, I'll put a video up here for you. But we're going to take our b term, which currently is 2, the coefficient of the b term. We're going to divide it by 2. And then square it, all right? That's kind of a weird process, but it works, okay? So 2 divided by 2 is 1, 1 squared is still 1, okay? And we're gonna add that in right here, plus 1. And again, if I do it to one side, I have to do it to the other side, so I'll put a plus 1 on the other side as well. All right, what this does for me is now this can be written as a binomial squared. And the way we do that is we take our x, right? We think what times what gives me 1 squared, that same what, and that's going to be 1. 1 times 1 is 1 squared. And then the sign that goes in between is the sign that comes in front of your b term. So this will be x plus 1 quantity squared equals, of course, on this side, just negative 2. All right, so why does this help? Because now I can take the square root of both sides. And over here, the square root and the square cancel, leave me with just x plus 1. And on the other side, the square root of 2, we can't really do it, right? Square root of 4 is 2, square root of 9 is 3, square root of 2, it's not going to work. And then also, square root of a negative is definitely not going to work. So what we have to do here is take this negative kind of out by saying this is now I times the square root of 2. Okay? Now lastly, to get our x isolated, right, we're solving for x. We still have a 1 with it. I have to move the 1 over by subtracting 1, just like this. And then that's going to give me my final answer. It's not no real numbers like our Photomath said. It's actually going to be x equals negative 1 plus or minus I square roots of 2. And I actually forgot something, right? Whenever I take the square roots, since I took this I out, I should have probably had my plus or minus up here. So that is our answer, and Photomath was wrong.